In this video, we are going to do problem 15.02, no dash numbers. All right. So I have the file download and open up in Racket. So let's just go over it. All right. I'm going to scroll down and look for the problem statement, problem A. So notice that the data design steps are done above. So let's just review those. All right. It's all checked off. So list of any is one of either empty or cons any list of any. And here's the interpretation. It's a list of anything, all right? And we're going to write the data examples in conjunction with the test, and you're going to see a test down below anyways. And here's a template that processes a list of any. All right. So design the function no dash numbers that produces a list of any where the numbers are excluded. So, for example, calling no numbers on this list that contains the string yes, the number 1, and the boolean false should produce yes and false, right? We don't want this number 1 here, right? We don't want any numbers in this list of anything, all right? Finish the uncompleted function design steps 1 through 5 above. So these steps here for the design of no dash numbers. Okay, so pause the video and try to work through this on your own. I'm gonna go with spoilers in 3, 2, and 1. All right, I'm assuming that you guys took a good swing at it. So now let's go over it together. So as always, signature no dash numbers consumes a list of any and produces a list of any. Purpose produces a list of any with the numbers excluded. All right, so this kind of just repeats the signature. So produces the given list, right, with the numbers excluded. That's a better description. All right, so signature, purpose, let's stub this out. So define no numbers S. I forgot the S here. No numbers, not no dash number. All right, so it consumes an any list. So I named the parameter any dash lst. Okay. So this produces a list of any, right? So we can use empty as a dummy value since empty is one of the list of any's. Let's do some tests here. So check, expect, right? Test examples. No numbers of the empty list, right? So there's, nothing in this list, right? There are no numbers in this list either. So we'll just produce the empty list. Let's do another example here of check, expect. No numbers cons 2 of empty, right? What should this produce? Well, there's a number in this list, and we don't want any numbers in this list. And since this is only a list of 1 long, we will produce empty, all right? Let's do one example where we actually do keep the thing right. So we'll do cons Doritos empty, like so. All right, what do you think this should produce? Well, it should produce, the list with the string Doritos, right? Because there's no numbers in this list. And we still want to produce a list of any at the end of the day, just with no numbers in this list, all right? So let me do the one more example. Let's just stick the number 7 in this list. Sure, why not? All right, so now there's Doritos and 7, all right? So we still want to produce the list with just Doritos in it. And of course, we can just copy and paste this example up here. So check, expect. All right, so cons yes on cons 1, false empty should produce cons yes and false. All right, so let's just run this code and make sure that it, runs tests and there are no typos with the tests. Tests are fine, it's just mismatches. I'm gonna comment out the stub here. Actually, I was right. I saw some red there and I was panicking for a second. Gonna comment out the stub here. Gonna grab the template here as the starter. Paste it down, rename no numbers. All right, so now really pause the video. Hopefully this should be all the mental scaffolding needed to write no numbers. Move over spoilers in 3, 2, and 1. All right, I'm assuming that you guys took a good swing at it. So now let's go over it together. Okay, so looking at all of our scaffolding here, right? Well, the base case is that we just, given an empty list, we should just produce an empty list. So that's our base case. All right, so let's look at the hardest part, right? What happens when there are things in the list, right? So we want to include things based on whether they're numbers or not, right? So, or not. So we're kind of dealing with decisions here. So the combinator is going to be an if. All right. So first of the AnyList, right? So let's focus on these two tests, right? Where the lists are cons2 empty and cons Dorito empty, right? So in this case, the first of the list is going to be 2. And in this example, it's going to be Doritos. So we need a function that consumes anything, right? You know, numbers, booleans, strings, etc., and determines if it's a number or not, right? So if you go and look at the documentation here, right, look at things that consume anything, right? So there should be like any here. In this case, you know, after some research, you will find that the function we need is number question mark, right? So it consumes n, and this n can be any /c, right? So that's what we want, right? We want to be able to pass strings to it and have it spit out a boolean telling us whether the value that we give it is a number or not, right? We don't want it to crash, right? So that's what these functions, these question mark functions, are for. All right. So we know we have to wrap this in a number question mark. All right. So what happens if it is a number? Well, we don't want it in the list, right? So we're going to do just calling no numbers on the rest of the list, right? So if it is a number, then we don't want it, right? We just continue on processing the rest of the list, right? All right. So let's move on to the false case, right? The false branch. What happens if it's not a number, right? If it's not a number, right, like the string Doritos or the boolean false, etc., then we want to keep that value, right? So what we need to do is, you know, looking at our signature here, we can deduce that we have to reduce a list, right? So this false branch, right, we know that we need to reduce a list from the signature itself. And also the examples tell us that we have to produce a list with cons, right? And so we need cons here for the false branch. So we want to keep the value, right? So the value is going to be first of the AnyList onto, right, the rest of no numbers on the rest of the list, which we will assume, again, will just work and follow the purpose statement. So let's just run this code and all tests do pass. Now for the final step, test, review, and refactor. All right, so as I mentioned, you can fan this out to rewrite this in a way that fans out the con cases, right? So we can just grab this condition from the if and just put it in the con branch, right? So that's the true branch. And then we don't need this if anymore, like so. So we delete it. And then 1 parenthesis on the left. Okay, same thing, just different style. It's up to you as to which one you prefer, nonetheless. And that is pretty much it. I recommend you submit this to Handin and make sure that you pass the server-side tests. For Handin, check the website on your score. All right. Anywho, I recommend you step through this function if you want to understand it mechanically or write things in a table format as you're working through the problem to understand and, you know, see things from a bird's eye view as to how you would combine it. And yeah. Anywho, that is about it for this one, and I will catch you in the next one.